Hello, how's everybody doing today? I was assigned the outflow and inflow, or net filtration and net reabsorption for the capillaries. So let's get right into it. To explain, this is the arterial and this is the venule. This is coming off an artery, this is coming off a vein. So what we have here is the capillary bed. And usually the capillary bed will be spread out over like a half circle on each end of each arterial and venule. If you know, for the most part, arteries are defined as going away from the heart. Venule is anything returning to the heart. There's a big misconception that red equals oxygenated and blue equals deoxygenated, or blood that is not supposed to be, the reason why it is like that is because in the heart you actually have this something called a pulmonary artery. And when we refer to an artery, if you don't know, we refer to it as oxygenated blood, which is not the case, because pulmonary artery is pushing deoxygenated blood out of the right ventricle through the pulmonary artery to the lungs to be oxygenated and for that gas exchange to happen in the areolus. So what is going on in the capillary? Let's get back to what's important. So we have the venule, arterial. For the most part, it is oxygen, but not always. So we have this oxygenated blood coming in from arterial. It's coming in, it's coming to this capillary. It's oxygenating all these tissues. Remember, capillaries are very small, and they stay on the outside, and it's called a capillary bed because of the space that it occupies, and it's spread out in many different layers. It's just not one string like represented here. So we have this oxygenated blood coming in. It's coming in, and it's coming in at 30 millimeters of mercury of hydrostatic pressure coming in. So it's coming in from arterial. Again, remember, since it's being pumped through the aorta, we have, the 120 millimeters of mercury coming through the aorta, and by the time it gets down to the capillary bed from the arterial, it's only at 30 now. So when it reaches 30, it's coming in here, and this oxygenated blood gets pushed out with the 30 millimeters of mercury. That's the hydrostatic pressure. But in between this space, there is interstitial tissue. And there's this interstitial space right here. And this is kind of sucking up blood. So you have this space pulling out. So this is how we get our 33 out on the arterial end. So the net hydrostatic pressure is coming out to 33 out. So we have a total of 33 going out. And at the same time, we have the colloid, oncotic pressure, which refers to, like again in lecture, refers to the proteins that are inside the blood, like albumin, globulin, everything like that. It's flowing through, doing that pulling force. It's because the reason why there's this pulling force. So pretend there's a rock and a water hose, and it's going down a tube. It's going to carry force with it once it's already been initialized. So once that protein's been pushed through, it's going to keep carrying and push through, because these proteins, these are red blood cells, by the way. There are proteins in the plasma pulling it to the venule. And this 20 millimeters of mercury for N is it's static. It does not change. So what we have is we have a total of 20 N. So you can imagine it, 33 minus 20, that gives us 13 out. So overall, the hydrostatic pressure wins, you could say, and it goes out. So you have this blood that is now out, 13 out. So now we still have that 13 out going across, but now since the pressure has changed, the hydrostatic pressure is only 10 by the time it reaches, because hydrostatic pressure drops when it travels along a tube. It's like having like a system of tubes that are open on either side, and there's only the main pressure is here. It's coming through and pushing up, but every time it passes and leaves fluid behind, it's going to go down. And so what you end up with is a lower hydrostatic pressure. Again, the oncotic pressure of 20 is still the same. 13 going out, 20 going in. That leaves us with a net of 7. So that 7 is going to be that pooling. So this is how we get like the deoxygenated blood, plasma, any water that's been pushed out. This will go into the venule, or back into the capillary, down the venule, and back into the venous supply. And this will cause this deoxygenated blood that was exchanged with the nutrients here and here. This will be pushed back to the superior or inferior vena cava through the veins, and there you go. And now you have a complete cycle. These have terms though. So filtration only happens at the arterial end. Reabsorption happens at the venule end. So filtration, we're basically filtering out the water that can be pushed out, or plasmas, or the water that can be pushed out along with its nutrients, oxygen, and so on and so forth. And then we have like this used blood that is coming through. I'm sorry, excuse me. Let me change this. So we have now this blood that's coming out. It gets used, bunch of oxygen, CO2, acids. These are all coming back through to be processed. So it can come back in here, comes in here, again, goes out, down, and then we have a complete cycle. Filtration, pushing out, reabsorption, reabsorbing, filtration, pushing, reabsorption, pulling. So that is everything that needs to be discussed. So this is how the capillaries are used with pressure gradients to supply the body and tissues with nutrients that are needed. If there's any other questions, just put them in the comments below. I'll be more than happy to answer them. Thank you and have a great day.